Hi everybody, this is your ever-loving JP sir welcoming you all once again to this wonderful physics class. And in this class, we are going to see about the force of attraction and the force of repulsion between two charged stationary objects by stating Coulomb's law. So this is a very important topic, grade 12 electrostatics, where this law is the most frequently asked question in the board exam. So dear students, let us all combine together and enjoy learning. Let us get into the class. Coulomb's law of electric force. To define Coulomb's law, let us take two charges. These are the two charges Q1 and Q2. One is the positive charge and the other one is the negative charge. And we know that like charges will be repelling each other and whereas the unlike charge will attract. So these are unlike charges. So there will be a force of attraction between the two charged bodies. And if we take these two bodies, which is Q1 and Q2, they are similar charges, positive charge, here also positive charge. So there will be a force of repulsion between the two charged stationary bodies. The same way, if we take a negative charge and a negative charge, there will be a repulsion between the two negatively charged stationary charges. So these two charges are now separated by a distance r. Let us consider like this now, the charges are separated by a distance r from its center. Now how to define Coulomb's law? Coulomb's law states that the force of attraction or the force of repulsion between two stationary charges is directly proportional to the product of the charges. Directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges. Now how to state or how to define the law? Now let us now write it in terms of expression. Force of attraction or the force of repulsion between two stationary charged objects is directly proportional to the product of the charges Q1 into Q2 and inversely proportional to the square of the distance, between the two charges. Now to remove this proportionality symbol, I am introducing a constant called K. So this K is the proportionality constant or it can be known as electrostatic force constant. K is proportionality constant or it is electrostatic force constant. Now we are going to see the value of K. What is the value of this proportionality constant? So from here all these equation can be written like this here. F is equal to K into Q1 Q2 divided by R square, which we can keep this equation as the first equation. Similarly, this equation can be rewritten as F is equal to the value of K can be written as 1 divided by 4 pi epsilon naught. K can be replaced by 1 divided by 4 pi epsilon naught, which you have to keep in your mind, where K is equal to 1 divided by 4 pi epsilon naught. Q1 Q2 divided by R square. So let us keep this equation as the second equation. And from these two equations, it is known that the value K or the proportionality constant K is equal to 1 divided by 4 pi epsilon naught. which we can keep it as the third equation. And from the third equation, we can even derive that this epsilon naught, which is known as the permittivity of free space. Epsilon naught is equal to 1 divided by 4 pi into k. So, this k comes down, epsilon naught goes cross multiplied. Here k comes down. So, where we are getting this equation, epsilon naught is equal to 1 divided by 4 pi into k. So, let us find the value of k now. From equation 1, we can write that k is equal to f into r square, cross multiplying f and r square and dividing by q1 into q2. So, the k can be expressed like this from equation 1. From equation 1, we are redefining k, that is k is equal to f multiplied by r square and divided by q1 q2. And the constant value found for k is equal to 9 into 10 to the power 9. And how we are writing this SI unit is, for force it is Newton. For measuring the distance can be measured with the SI unit meter square. So, distance square, so meter square. And here the product of the charges, Coulomb into Coulomb, which will be giving you Coulomb square. So, when Coulomb square goes up, it becomes Coulomb minus 2. So, this value is a very, very important value which we will be using in most of the numericals. So, we have to keep in mind that the value of k is equal to 9 into 10 to the power 9 Newton meter square Coulomb minus 2. So, everybody should keep this value in our mind. This is the value of k. Let us now come to this part, that is taking the equation 4 now. Epsilon naught is equal to 1 divided by 4. For pi I am writing 3.14 and for k I am substituting this value. So, k is equal to 9 into 10 to the power 9 Newton meter square Coulomb minus 2. So, epsilon naught is equal to 1 divided by, I am multiplying 9 and 4. 9 fours are 36 into 3.14 and taking this 10 to the power 9 to the top, it becomes 10 power minus 9. And here the unit is below 1. So, when I take this unit to the top, Coulomb to the power minus 2 becomes Coulomb square, Newton become Newton minus 1 and meter square become meter minus 2. So, this is also very, very important. For k, the SI unit is Newton meter square Coulomb minus 2, whereas the SI unit for epsilon naught is equal to Coulomb square Newton minus 1 meter minus 2. So, let us now multiply these two terms. 1 divided by 36 into 3.14, where we will get 113.04 into 10 to the power minus 9 Coulomb square Newton minus 1 meter minus 2. Again, epsilon naught is equal to 1 divided by, so this what I am doing is, I am making it as 1.1304 multiplied by 10 square into 10 to the power minus 9, 1 into 10 power minus 9 divided by 1.1304 into 10 square. Unit I am writing Coulomb square Newton minus 1 meter minus 2. 1 divided by 1.1304 into, so this 2 goes up, it becomes 10 to the power minus 2. So, that we are getting 10 to the power minus 11. And dividing 1 by 1.1304, we are getting the value as 0.8854 into 10 to the power minus 11, where we can write this as 8.854 into 10 to the power minus 12 Coulomb square Newton minus 1 meter minus 2. So, in this class we have studied what Coulomb's law states, very, very important law, which states the force of attraction or the force of attraction between the two objects, taking the product of the charges into account and taking the distance of separation between the two stationary charges. And apart from that, we also came to know what is K here. K is nothing but the proportionality constant, or it is the electrostatic force constant, where we have found the value for K. K is equal to 9 into 10 to the power 9 Newton meter square Coulomb minus 2. 1 mark every time this can be asked, the unit will be asked, what is the SI unit for the proportionality constant. So, it is Newton meter square Coulomb minus 2. And also all these equations we have written here. From that equation we are deriving the value for epsilon naught, which is nothing but the permittivity of free space, and we are finding the value as 8.854 into 10 to the power minus 12 Coulomb square Newton minus 1 meter minus 2. So, these two values we have to keep in our mind along with the SI unit. So, I hope that in this class you could have come to know what Coulomb's law states. I hope that all would have enjoyed this class. Thank you for watching. Let us meet again in the next class. Have a nice day.